Hi, welcome to my channel pibyme Maths. This is by WST01. Here we are solving October-November 2019 Statistics 1 paper. Let's look at question number 1. Jeremiah is investigating the relationship between the annual heating bill $H and the total floor area F square meters of buildings. A random sample of 8 buildings is taken and the data for each building are coded using this. Okay. The result for the coded data are summarized below. Find SXY. The formula for SXY is sigma xy minus sigma x times sigma y over n. Since sigma y is 0, this whole thing will be 0, so the answer is going to be sigma xy. So 1818, that's all. Part B now. Find the equation of the regression line H on F in the form H is equal to A plus BF. So let's find B first. The formula is SXY over SXX. We just calculated SXY 1818 over 1818 over SXX is given here 1754. And then we need to find A. The formula is Y bar minus BX bar. Since sigma y is 0, this whole thing is 0 minus B, whatever the value we are calculating here, times sigma x. So sigma x is 5 over 8. 5 over 8. So let's calculate the B first. 1818 over 1754. Gonna store the values. B 1.036 dot 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 dot. So 1.036 ... times minus 1. That's minus B times 5 over 8. Will give you the value of A minus 647 minus 0.6478 dot dot dot. We might need the value, so I'm going to store it as A. Okay. Now take the values to 3 significant figure. The equation of the regression line Y is equal to A plus BX. A 6478 dot 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 plus B X, but they want the regression line equation of the regression line of H and F. So that's when we are going to use this coding given. Replace X by this, Y by this. So the equation is going to be H minus 4500 by 80. Replace Y by this is equal to A, do not round the figure now, plus B times X. Replace X by this, F minus 3500 over 80. F minus 3500 over 80. Now we have to make H as a subject now. So first thing first, I'm going to multiply throughout by 80. So H minus 4500 is equal to, here I'm going to get 1.0036 dot 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 F minus 1.0036 times 3500. When I open the bracket, the 80 will be cancelled. Here I'm going to get this times 80. So the value of A times 80. So minus 51.82 dot dot. Okay. And then if I bring this value here, I need to add 4500 to it, plus 4500, and then minus this, minus 3500 times the value of B. So I got 820 point something. Okay, h is equal to 820.467 plus the f is the value of a got only 10, not 00 actually. 36 36. So even when I multiply it, yep, 36 . So f is 1.036 f. So if you round it to three significant figure, h is 820 plus 1.04 f. That's the required regression line of h on f. Part C now. Give an interpretation to the value of b in your regression line. Okay, the regression line is h is equal to 820 plus 1.04 f. This is a, this is b. So they want you to give the interpretation of the gradient. Okay, when f is 0, h is 820. When f is 1, if you increase f by 1, h will be increased by 1.04, right? So when you increase f by 1, h will be increased by 1.04. So we need to find out by reading the question, what is f and h here in this context? So if you read the question carefully, f is the total area. Annual heating bill is h. So for every one increment in f will result in 1.04 increment in h, right? So we need to write it as a sentence actually. So on average, every increase in the flow area of 1 square meter square, the annual heating bill increases by 1.04. That's the answer for I. So you just need to write this sentence, that's all. For double I, find the value, interpret the value of a, the y-intercept. So when you replace f by 0, h is 820. That means even there is no flow space, still the heating cost is 8. That's the base cost actually. So you need to write the cost of heating is 820 even if there is no flow space. That's how you interpret the values. Part D. Estimate the annual bill for a building with a total area of this. Okay, we know this. The regression line is 820 plus 1.04 f. But instead of these rounded values, we have to use the actual values actually. We have only the a, right? Okay, I'm going to store this value as a here. Okay, 1.04 was a rounded value, but the b was the actual value, right? Yes. Okay, so we are going to use the actual values, not the rounded figure, and we replace the flow area f by 4600 square meters. So h is 820 point whatever the value plus 1.036 times, always use the actual value. So that's basically a plus b times 4600, 5588.31, etc. You can round it to three significant figure and write it as 5590. That's all. Question number 2. The histogram shows the time taken in seconds by each of 260 people to complete a puzzle. Okay. Use histogram to complete the frequency table for the time taken to complete the puzzle. There are two missing values here. So whenever you get a table with some missing values and a histogram, this is what you should be doing. Take one of the bar from histogram with the known frequency and the class interval. You can take this, or this, any one of this. Okay. So for example, I'm going to look at the histogram. Okay, let me put the histogram a bit bigger here. Okay, this is the histogram, and then if you look at the table, the class intervals are 15 to 30. Okay, let's look at this bar. This is 15 to 30, right? What's the height of the bar? Okay, first of all, we need to find these missing values, correct? Frequencies. Okay, so I'm going to take the first bar. Here, the frequency density is frequency over the class width. Class width is a difference between these two. 15, which is 20 over 15 is 4 over 3, 1.33 something, right? That should be the height of this bar, because height is marked by using this frequency density, right? So for this particular bar representing this class interval, the height should be 4 over 3, 1.33. Now let's look at the bar. Now here the height is, let's say this is 1. So it's basically 0.8 actually for this bar, right? Okay, now back to this. It's supposed to be 4 over 3, but they have used 0.8 because they have used some scale factor. That's what they do when they draw the histogram. They don't use the actual class width or the actual frequency density. Sometimes they use some scale factor to reduce it or increase it. Okay, now let's take this one, 45 to 55, and call it the frequency as F1. So the height of the bar should be F1 over the class interval. The difference between these two is 10. That should be the height of the bar. But now let's look at the histogram and check what is the actual height there for 45 to 55. Okay, 45 is in here, 55 is in here. The height of the bar is, this is 1, 2, 3, 3.9 is the height, right? 3.9 is the height. So you cross multiply, you will get the value of F1. So it's going to be 4 over 3 times 3.9. Okay, F1 over 10 times 0.8 is equal to 4 over 3 times 3.9. Make F1 as a subject. So 4 over 3 times 3.9, calculate this first, times 10 over 0.8. 65 is the answer. So the answer here, F1 is 65, and this should be your working. This diagram is just for your reference. So we are going to do the same thing to calculate F2 now. Okay, use the same thing, first bar here, and then F2 over the class interval 60 minus 55 is 5, that should be the height of the bar. Now let's look at the bar 55 to 60 here. What is the height of the bar? 55 to 60, 55 here, 60 here. The height is, this is 1, this is basically 1.8, right? So the actual height is 1.8. Okay, now let's cross multiply and find the value. So F2 over 5 times 0.8 is 4 over 3 times 1.8. So 4 over 3 times 1.8 times 1.8, and then times 5 over 0.8. 15 is the answer. F2 is 15. So this answer is 15. That's how you solve it. Part B now. You have sigma ft square given. Find an estimate for the mean time taken. For the mean, the formula is sigma fx over sigma f. So 11087.5 divided by what's sigma f? Sigma f, you need to add all the sigma, but it's given here already, 260. 260, you will get this answer. Double for standard deviation, the formula is square root of sigma fx square over sigma f minus the square of the mean, which is square root of 505718.75 over 260 minus, let's find this value, put it here and square it. So what's the mean first? 11087.5 divided by 260. Okay, 4435 over 104. You can write it as 42.6 also to 3 significant figure. But when you use here, use the actual value, 4435 over 104 whole square. Okay, square root of 505718.75 over 260 minus 4435 over 104 whole square. 11.249 round it to 3 significant figure, 11.2. Part C, use linear interpolation to find the median Q2. So I have put the table here. The two missing values are 65 and 15. 65 and 50. To apply linear interpolation, you need to find cumulative frequency first, which is 20 plus this 165 plus this 230 plus this 245 255 260. This should be equal to sigma f, which is given in the question as 260, right? Okay. Now to find the median Q2, you need to take sigma f divided by 2. So 260 divided by 2 is 130, and check where this 130 lies in the cumulative frequency. Anything above 20 less than 165 lies in here, right? So 130 lies in here. So take the class interval. The class interval is 30 to 45. So your Q2 must be somewhere in between. Now take the corresponding cumulative and the previous cumulative, 20 and 165. Write this value here and apply linear interpolation. Q2 minus 30 divided by 45 minus 30. Q2 minus 30 divided by 45 minus 30 is equal to, do the same thing at the bottom, 130 minus 20 over 165 minus 20. That's all. Make Q2 as a subject. So you can write Q2 is equal to 110 over 145 times, this goes to the other side, which is 45 minus 30 is 15 plus 30. So 110 over 40, 145 times 15 plus 30. So if you round it to 3 significant figure, it's 41.4. That's a linear interpolation method. You can use the method to find Q1 and Q3 also. Now part D, describe the skewness of the data. So I'm going to show you a figure. You can take note of it. When you see these conditions are satisfied, it's a positive skewness. When the histogram is more skewed towards this origin 0, Q2 is closer to Q1. When it's closer, this distance will be smaller than this distance, right? Or mean is bigger than median is smaller than mean. If it's smaller, when you subtract them, you'll get a positive number. These are all the conditions for positive skewness. Okay. Now in this question, we have the mean here 42.6. We have the median here 41.4. So you can write median is smaller than mean, therefore positive skew. That's all. Part E now. 3 of 260 people are chosen at random. Estimate the probability that all 3 of their times are less than 36 seconds. So you need to find how many of them have taken less than 36 seconds. Okay, from the figure, 20 of them taken 15 to 30 and 36 is somewhere in between. So we need to find out of 145 how many of them have taken 36. So what we are going to do, we can divide 30 to 45. This is just for your reference, okay? Into equal trees, actually equal portions. So I'm going to write it as 33, 36, 39, 42. So I have taken into 5 equal portions. So divide this also by 5. So 145 divided by 5 is 29. So you will have 29 people in each portion. So we are interested in till 36 only. So you need to take 29 plus 29. But in the exam, you cannot just draw this figure, right? You need to show the working. So this is basically 2 portions of the total 5 portion, right? So you can write number of people is equal to 2 out of 5 times 145 plus the earlier one, there are 20 of it. So you will get 2 over 5 times 145 plus 20, 78 of it. Therefore, the probability of people who have taken less than 36 seconds will be 78 over 260. 260, 3 over 10. That's the probability, 3 over 10, right? Or you can just keep it as 78 over 360 because we'll simplify at the end. Okay. Now we are choosing 3 people from this category. So when you choose the first one, the probability will be 78 over 260 times. When you choose the second one, the total count will be down by 1. The number of people will be down by 1. Total also will be down by 1. And when you take the third one, it's going to be 78 over 258. Just calculate this probability. So 78 times 77 times 76 over 260 times 259 times 258. Okay, 0.0263 is the answer. So 4 more questions. Question number 3 now. The distance that Jenny throws a javelin is normally distributed with mean 42 meter, standard deviation 5. So I'm going to write it as x follows normal distribution of 42, 5 square. Part A, find the probability that the distance Jenny throws the javelin is less than 40. X is less than 40. Standardize it, z is less than x minus mu over sigma. That's P of 2 over 5 is minus 0.4. So the area on the left hand side of a negative number is same as 1 minus the area on the left hand side of positive number. Let's use the table value for 0.4. 0.4 is in here. 6554. 0.6554, 0.3446 is the answer. You can leave it as it is, or you can round it to 3 significant figure 345. Okay, and that's the answer for part B. Part A. Let's move on to part B. Jenny enters the javelin competition. To qualify for the final, she has 3 attempts. Okay, she has 3 attempts. Let's take it as 1, 2, 3. She has 3 attempts to throw the javelin a distance of more than 40. Okay, if she throws more than 40, she qualifies for the final. Okay. Once she has qualified, she does not use any of her remaining attempts. Okay. Given that, it's a conditional probability, given that Jenny qualified for final, qualified is the condition. For the final, qualified for the final, that throws of the javelin and the throws of the javelin are independent. Okay. Find the probability that she qualified further on her 3rd row. She failed here, she failed here. She qualified on the 3rd throw with a distance more than 45 actually. Okay, so you can put it as x is greater than 45 here, P of, right? In the 3rd throw, you can write it this way, P of qualified in 3rd throw with x is greater than 45, given that qualified. That's the probability we need to find. Okay, now to qualify she has to throw more than 40, right? But we calculated less than 40, which is this, right? This one, 3446. So more than 40 will be 1 minus this. Okay, so I'm gonna take the probability as 0.6554. That's more than 40. P of x is more than 40 is 0.6554. P of x is less than 40 is 0.3446. So far so good, right? Okay, so we are going to use the conditional probability. Let's take this as A, this as B. The formula is P of A intersection B divided by P of B, correct? So we are going to calculate the numerator and denominator separately. Now look at the denominator, P of B, that means P of qualified, right? Just qualified, not in the 3rd row, it's just qualified. That's a condition, given that Jenny is qualified for the final. Qualified means she has thrown the javelin more than 40 in maybe in first round, first throw or 2nd throw or 3rd throw. So I'm going to calculate P of B now. So listen me carefully. P of B, B is qualified. Okay, she threw the javelin maybe in the first throw or 2nd throw or 3rd one, right? So if she throw the javelin more than 40 meter in the first throw, the probability is 0.6554 plus. In the 2nd throw, that means first one she failed, 2nd one she succeeded, right? Q and P. This is Q, this is P. So she qualified in the 2nd row, means in the first row she failed 3446 times, but in the 2nd row she succeeded, plus. Or maybe she succeeded in the 3rd throw, that means first to fail times she succeeded in the 3rd throw, right? That's a probability of she being qualified. We need to find this probability, that's a denominator. So let's calculate this first. 0.6554 plus 0.3446 plus 0.6554. Sorry, times actually. Times that's she qualified in the second row, plus 0.3446 square times 0.6554. You got this answer, 9590, 0.9590 dot dot dot. I'm gonna store the value as a. Okay, so we calculated the denominator already. So let's calculate the numerator now. Numerator is A intersection C. What is A intersection C? She qualified and intersection of this. That means she qualified but in the third row she throwed more than 45. So think about it. P of A, the numerator. She qualified in the third row. So the first one and the second one she failed, but in the third row she succeeded. But we don't use this probability of success, we need to use this probability of success. X is 45. Hope you understand this. The first two she failed, that's why I put square here. Okay, but in the third row she succeeded, but she has thrown more than 45, not more than 40. So we have to basically calculate this actually. So keep this as it is, 3446 whole square. Standardize this. Z is greater than 45 minus mu over sigma, which is Z is greater than 0.6. So 0.3446 square times P of Z is greater than 0.6, which is 0.3446 square times the area on the right hand side is same as 1 minus the area on the left hand side of 0.6. So we need to calculate this actually. So you're going to get, let's look at the table value for 0.6. 0.6 is in here, 7 to this one, 7257. 0.3446 square times 1 minus 0.7257. That should be the numerator. Now you can find the probability P is equal to the numerator 3446 square times 1 minus this is 0.2743 divided by this is a probability of denominator 0.9590 dot dot dot. Hope you understand this. So the numerator is 0.3446 square times 0.2743 divided by, I stored the value as a 0.3396. When you round it to 3 significant figure, you'll get 0.034. Yeah. Let's read the question for the level of accuracy. Nothing is mentioned. That's a 5-mark question. You have to understand this question carefully. It's a little trickier one. Let's look at question number 4 now. A random sample of 10 boys A, B, C, D, E, F, G, H, I and J is taken from a junior athletics club. Each boy selected is asked to run a 100-meter race and a 200-meter race. Okay, this is 100-meter race, 200-meter race. I put a diagram a bit bigger here. As you can see, this is a time taken for 100-meter race, time taken in seconds for 200-meter race. Okay, now the time taken X seconds by each boy to run 100-meter race is recorded, and the time taken Y seconds by each boy to run 200-meter race is recorded. The results are plotted in the scatter diagram below. This is a scatter diagram. Part A says, state without calculation which of the 3 values below is most likely to be the value of PMCC. Okay, definitely it cannot be this, because if you look at the scatter diagram, there is a positive correlation, right? You can always draw a linear line with the positive slope. So there is a positive correlation. So if there is a positive correlation, the value of R should be closer to positive 1. So this value is not closer to positive 1. So cannot be this value, and we are left with 2 more values, right? But always remember, the closer the value of R to positive 1, the stronger the positive correlation would be. The same thing for negative also. The closer the value of R to -1, the stronger the negative correlation would be. So in this case, it can be 0.95 or 0.72. There are two values. Now, when you look at the diagram, the points are closer to the line, but there is one point here and one point is just away from the line, not closer to the line. So even though it's a positive correlation, it's not strong positive correlation. So we cannot take 0.95 because that's a strong positive correlation. That means all the points should be closer to the line. So the answer here is 0.72 is the answer. Okay. And then part B. In the sample of 10 boys, one is a junior champion 100-meter runner. Okay. And one is a junior champion 200-meter runner. Okay. Write down the boy who is most likely to be the 100-meter junior champion. Okay. This is the time taken by the 100-meter by the boys for finishing the 100-meter race, right? So the champion is the one who has taken the less time. So definitely C is the one taken less time. So C is the champion for the 100-meter junior 100-meter race, right? So you can just write C here. The data for the junior champions are removed. 2 junior champions are removed and the remaining data are summarized below. Okay. The data for the 2 junior champions are removed. So there are total of 10 of them. The question says 10 boys. Now they removed 2. So N is equal to 8 now. So C part I, find the PMCC. You have SYY, SXY. You need to find SXX first, which is sigma x square minus sigma x whole square over N, which is 3445.26 minus 164.4 square over 8. And then PMCC R is, the formula is SXY over square root of SXX times SYY, which is 60.85 divided by square root of SXX we are calculating. SYY is 67.52. So let's calculate SXX first. 3445.26, 3445.26, yes, minus 164.4 square divided by 8. 66.84. So use 66.84 here. 60.85 over, that's SXY, square root of 66.84 times 67.52, 0.9057 and then round it to 3 significant figure. 906. Okay, double I now. Comment in context on the value of the PMCC that you obtained in part 1. This is a value of PMCC which is close to 1, right? If it's close to 1, positive 1, that means there is a positive correlation. So what does that mean in this diagram? If this increases, right? So here, that means these both are positively correlated. That means if someone is taking less time to complete 100-meter race, he's faster in 100-meter race, definitely is going to be faster in 200-meter race also. So you can write, the faster the boys, the faster boys are in the 100 meters, the faster they are in 200 meters. That's all. Just a one mark question.